Okay, so here's our challenge problem from last time that you guys so graciously agreed to go through again with me. I appreciate that. So let's think about this. How many points of contact do you actually have here? 3, right? We've got A, B, and C. Alex, do you see that? We've got an A, a B, and a C, okay? So when I go to set up the chart, I want to think about that, right? So that I know how many columns and rows to have. And then how many outputs am I actually looking at in this case? Just 1, right? Sometimes we can have 2 or more outputs, but in this case we kept it simple. We just have this motor, right? So let's take a look at how we can do that. To set up the chart, remember, it's always binary because you're just choosing between 0s and 1s when you fill in the chart, right? And so our formula for how many rows we're going to need is always going to be the exponent of 2 to some power, and then what that exponent becomes depends on how many relay contacts we have, right? And we have 3 in this case, so that's going to give us 8. Everybody good with that? So if you go to set up your chart, you've got A, B, C, and then your output, which in this case is a motor. Oh, hold on, guys. Let me unfreeze. There we go. Is that better? So we've got 2 to the 3rd, because it's binary, 0s or 1s are our choices, and 3 because we've got A, B, and C. And then we need to comment on what we're doing with each one of those, and then how that affects the output, right? And when you go to set this up, I would ask, please, that you always, let's just look at that for the moment, that you always start with the first contact having, if you have 8, half of them have to be 0s, half of them have to be 1s. So just do the 4 0s and then do the 4 1s. So I'm asking you basically to always start with the 0, okay? And we know that you have to have 4 of each time, so you go 4 and 4, and then 2 and 2. Did you flip it, Alex?
They're all in random order.
They're in a random order, okay. And for now, that's fine, but I'm gonna ask you guys, would it be okay if we didn't do random order? Do you guys see how this works? Can you see the pattern? Does it make sense to you? Then it doesn't make sense to you. Okay, so for the first one, like you have 8, right, obviously? All right, 4 of those have to be 0s, and 4 of those have to be 1 for every single contact, okay? So what I'm saying is, since you know you have to have 4 and 4, and you want all the different combinations, right? So you go, okay, I'm just gonna get the 4, I'm always gonna start with 0. So for A, I'm gonna do 4 0s and 4 1s.
I see the pattern now.
Do you see it now? And then I'm gonna go 2 by 2s.
And then by 1s.
And then I'm gonna alternate. That's all you're gonna do, okay? And as long as you always start with 0 here and follow that, piece of cake. And I actually think you'll find you fill it in quicker because you've got a pattern. You're like, I know what I'm doing here, okay? So that's how I would ask you to fill it in, but you didn't do it that way this time, that's fine, all right? Might be a little bit harder for you to interpret my outputs, but I think we'll deal with that. All right, so let's talk about this. If you don't change anything, so here's the thing I wanted you guys to think about. The first one should be super easy because you're not changing anything. So all you're gonna do, Alex, is you're gonna look at your output. In this case, there's just 1, right? And the first thing you wanna do, though, in my opinion, is when you look at that output, ask yourself, how many paths are there from the positive terminal over to the negative side, okay? Because that's going to tell you whether you're dealing with sort of an and or an or statement. If there's only 1, then it's an and statement, okay? But if there's more than 1 pathway, then if 1 works, this is going to change. If it can get across to 2, this is going to change. If it can get across to 3, there's a potential for change. Does that make sense to you guys? So what you want to do is literally, you want to start by looking and saying, first of all, is this motor on or off right now? In other words, do any of these paths, if you will, allow the current to get from the positive to the negative side? Do any of them allow for that? No. And how do we know that, Alex? How do we know none of these allow for that?
Because like one's on, one's off.
Yep. So that's not going to work because this is an and. This is an and and this is, there's just one, well, there's just one there, right? So you've got three paths, which is in a sense sets up an OR, but within that OR, you've got the three paths, and this is an and, this is an and this is obviously a singlet, right? But if it can't get across any of those, then you start out saying that this thing is off, okay? And then you say, all right, what happens if I just change C, okay? So if I just change C, is that going to fix the problem if I only change C?
Yeah.
It actually does. It doesn't fix it here, but it'll fix it here, right? So because this was off initially, because we didn't have a path, but now we do, okay? And we're not changing A, so that path wouldn't work. What I did, just to help you guys sort of see the thought process also, notice I put a 2 there. Why did I put the 2? Because that's the pathway that it could affect the motorbike. Does that make sense, guys? You don't have to do that. That's just my way. Alex, put the drink down. You got to pay attention, man. Okay?
That's all right.
That's all right. Okay. So what do you guys think happens if, let me fix this. Let's say we only change B.
The first one is gonna change. It's gonna be able to go through.
Okay, good. Yeah, if I only change B, and once you find a pathway that works, you don't have to check all the other ones, right? You only have to keep checking if you're not finding one that's going to change it. In this case, if we only change B, that's where we are. If I change that and I don't mess with C, obviously right there, I know this is going to go on, okay? Now what I did, if there was more than one pathway, sometimes there is, I marked them just for completion's sake. But do you guys feel like you understand what we're doing here? I mean, this isn't a big deal. Do you want to see the other answers just so that you can check to see if you got it right? Alex?
What is when A is switched, that means all of them are on, right?
Yeah, anytime, let's face it, anytime we change A, that's another thing you can look for. Is you can go, is there a simple way that I can answer some of them very quickly? And because A is a single relay contact there, yes. And the minute I change A, this gets juice. So for these 4, I can immediately go on, right? So it's really just these up here that I have to kind of stop and think what's happening, right? Everybody okay with that? All right. Because these 4 up here, I don't change A. So I only mess with B or C, so that means that if that doesn't fix the problem, then it's going to stay off, right? Okay, everybody good with that? So you guys just want to kind of see the answers then. Looking there. And you don't have to put the numbers. This was just me showing you like a way of sort of thinking through it. You're just looking for a pathway that's actually going to change this, okay? Because initially it wasn't on. So then we have to look and say, if I change things, is that going to kick that on or not? That's really just kind of wanted to put that out there, okay? You guys all right with that? All right, so what I'd like to do now then is let's look at another one, and I can't remember. You guys might have already done this one also, but if you don't mind doing it again, this one is maybe a little bit more interesting. So if you don't mind drawing that on your paper. I'm gonna